Welcome back to the trig videos. We're going to talk about the law of sines right now. I have these two triangles drawn because when you do a law of sines, you're either going to be using triangles that are side angle side or triangles that are side side side. Remember with the law of sines, you had to have an angle and then the side opposite that in order to do a law of sines. So neither one of these triangles would qualify for that. So we need to have another strategy. This is the law of sines. If triangle ABC has sides of lengths A, B, and C as shown, then A squared is equal to B squared plus C squared minus 2BC cosine A. And then these two formulas are actually just the same one. They're just switching the variables around. You have one side squared is equal to the second side squared plus the third side squared minus 2 times the second side times the third side times the cosine of the angle that's opposite this. So this is a side angle side problem, and what I need to do is solve the triangle. When you solve the triangle, remember that means that you have to find all of the angles and you have to find all of the sides that aren't already listed. So I can't use a law of sines. I really like law of sines because it's nice and short. Remember, you've got the sine A over A equals sine B over B. But here I don't have that option. So I'm going to try to find side B, and I'm going to use the law of cosines. So B squared is equal to A squared plus C squared minus 2AC cosine B. Now you can have your triangle either in radians or in degrees, it doesn't matter, but just make sure that whichever you're at, here I'm in degrees, I want to make sure that my calculator is in degree mode when I solve this. And B, I could have written, is 95. So I want to solve for B. I can put all of this on my calculator. Make sure you put parentheses around the 95 and then take the square root. So B is about 26.2. Now, once I have this, I could do another law of sines, or sorry, law of cosines if I wanted to. But you know, law of sines is so much quicker, I think, so that's what I'm going to do. I'm going to say sine 95 over 26.2 is equal to sine A over 21. 21 is opposite side A. And I want to solve for A. So I would do a product of the means equals product of the extremes, and I'm going to have to use the arc sign or the inverse sign to find A. So A is approximately 53 degrees. And now the last one I have to do is find C, and angle C is just 180 minus 95 minus 53, so that would be 32 degrees. The next example is one where we're given 3 sides and no angles at all. So I need to use a law of cosines on this to begin with also. And I'm going to find angle A, no reason, I'm just going to find angle A first. So I would use my law of cosines. A squared is equal to B squared plus C squared minus 2BC cosine A. When I solve for cosine A, I have cosine A is equal to 6 squared minus 4 squared minus 9 squared divided by negative 2 times 4 times 9. So I want to calculate this, and then I'm going to do second cosine, second answer on my calculator. Second cosine, second answer. And I get A is about 32.1. And now, since I have now an angle and the side opposite, I can use my law of sines, which is quite a bit quicker than the law of cosines, I think. So I have sine 32.1 over 6 is equal to, and I'm going to find b, not because it's in order A, B, C or anything, just because I feel like it. Could find c just as easily. And b was 4, so I should write 4 instead of b. And I want to solve for b. Make sure when you're doing this, you're doing product of the means equals product of the extremes. And make sure you're in degree mode, and you're going to be using the arc sign or the inverse sign to find b. And b is about 20.7. So if b is about 20.7, c is going to be 180 minus these two angles, which would give me 127.2. You notice that my triangle is not to scale at all, and that doesn't matter. I just like to have the triangle here so I can see the angle on the sides opposite, and the angles as I go around the triangle and the sides in the proper order. Just makes it easier to use the formulas.